Good morning. Today we are going to discuss expected value and variance of a random variable. First we discuss expected value. Let x be a discrete random variable, capital X I mean, taking values x1, x2, x3 up to xn with probabilities p1, p2 up to pn. Then the expected value of the random variable, which is denoted by E of x, is defined as E of x equal to what? It is x1 p1 plus x2 p2 up to xn pn. So using sigma notation, what is E of x? It is nothing but sigma xi pi. I goes from 1 to n. Usually we just write sigma x into p. Actually it is sigma xi. I goes from 1 to n. Now we are going to prove that expected value, which is also called as mathematical expectation or simply expectation, is nothing but arithmetic mean of x. I repeat, we are going to prove that expected value of a random variable, which is also called as mathematical expectation or simply expectation, is nothing but arithmetic mean. I hope you remember the formula for arithmetic mean. What is arithmetic mean? Sigma fx upon sigma f. So it is sufficient to prove that E of x is nothing but sigma fx upon sigma f. So let us prove that. Let x1, x2, x3 up to xn be the values of the random variable with corresponding frequencies f1, f2, f3 up to fn. What is the meaning of frequency? This only means that if total number of sample points is sigma f, that is capital N, then f1 sample points are in favor of x1. F2 are in favor of x2 and so on. Okay, so I write probability distribution as these are the values of random variable x1, x2 up to what? Xn. Then we, in the second row, we write probabilities. Okay, now out of total sample points, which we denote by sigma f or capital N, f1 are in favor of x1. So what is probability? It is f1 upon capital N. Note that capital N is nothing but sigma f. Now, out of capital N sample points, total number of sample points, f2 are in favor of random variable x2. So what is its probability? F2 upon n up to Fn upon capital N. Okay. Here I write that what is capital N? It is nothing but sigma f. Now what is the formula for expected value? Expected value E of x is nothing but sigma xi pi. I goes from 1 to n. So this is nothing but x1 into what? F1 upon n plus x2 into what? F2 upon n till xn into fn upon n. Now I can write this as expected value equal to sigma fx. Actually, I should write sigma fi xi. I goes from 1 to n, but I'm just writing sigma fx upon capital N. What is capital N? It is nothing but sigma f. Note that this is formula for arithmetic mean. Now, arithmetic mean of which variable? X. So, arithmetic mean is denoted by x bar. This proves that E of x is nothing but x bar. See, I already uploaded the proof on that rather the proof is included in that file which is already uploaded. I don't think this proof will be asked in the exam, but if you know the proof, result can be remembered easily. So it is expected value, which is also called as mathematical expectation or simply expectation. It is nothing but the mean of random variable. Now this expected value can also be denoted by mu or mu x. Now what are the properties of this expected value? Properties are, what is E of x plus c? Basically, expected value is arithmetic mean. So if you know this definition, then what is E of x plus c? It is simply E of x plus c. Why? Because c is nothing but a constant. Okay. Then what is E of cx, where c is constant? It is nothing but c E of x. And then the third one, what is expected value of constant? It is that constant only, right? Because if each observation is just a constant c, then what is mean of that? It is that constant only, right? So in other words, expectation of a constant is the constant itself. Then comes definition of variance. See, we have done this in statistics in 11th standard in the topic measures of dispersion. If x is a random variable taking values x1, x2, x3 up to xn with probabilities p1, p2, p3 up to pn, then variance is defined. It is defined as v of x equal to e x minus x bar square. I repeat, variance is defined as e of square of what? X minus x bar. What is this x bar? This x bar is nothing but mu x, that is expected value of random variable. Now, can we simplify this? I mean, can we simplify this part? Yes, we can. How? E of what? What is a minus b bracket square? It is a square minus twice ab plus b square. Again, this will not be asked in exam, I mean proof, but I'm going to explain it. So this is what? E of x square minus 2x bar, which is constant, E of x. Okay. And what is expected value of constant? It is that constant only. So this is nothing but E of x square, okay, minus twice x bar. What is E of x? It is nothing but x bar only. Expected value is nothing but arithmetic mean plus x bar square as it is. So this is nothing but E of x square minus x bar square. So I can say that variance x is nothing but E of x square minus x bar square. But what is x bar? It is E of x. Okay. So what is variance? It is E of x square minus square of E of x. Okay. Clearly, variance x. If you remember, variance is always non-negative. It is never negative. And that is why we define standard deviation. Standard deviation, standard short form is SD. How SD is defined? It is defined as positive square root of variance. And what is variance of x? It is E of x square minus square of E of x. I hope this is clear to you. Now, the variance or the standard deviation is a measure of dispersion, right? And what is dispersion? It is tendency of observations to differ from each other. Usually, we consider the deviation, that is differences of all observations about mean, that is expected value. Okay, so you have to remember two formulae. What is expected value? E of x. It is just sigma xi pi. I goes from 1 to n. What is variance of x? It is e of x square minus square of e of x, and standard deviation is positive square root of variance. In exam, you are allowed to use log tables to find the square root. Write down this. Exercise 7.1, 9 sum. Find expected value and variance of x for the following probability mass function. So we have to make table. First column is headed by values of random variable, capital X equal to xi. Second column, probability. Third column, xi pi. And for variance, we need what? E of x square. So what will be E of x square? It will be nothing but sigma x square p. Now just multiply this product by xi, you get this. Okay. So make the table and tell me the values. Yes, so these are the entries. What is sigma xi pi? It is minus 0.05. Then what is sigma xi square pi? It is 2.25. So expected value is sigma xi pi, that is minus 0.05. E of x square is sigma xi square into pi, that is 2.25. Now how variance is defined? E of x square minus square of e of x. So 2.25 minus square of this, square of negative number is also positive. So 2.25 minus 0.0025. So 2.2475 is nothing but variance. If we are asked to find standard deviation, we have to consider its positive square root. Standard deviation is positive square root of variance. Sum number 10. Find expected value and variance of x, where x is number obtained on the uppermost face when a fair die is thrown. See, fair die is thrown. So all these events are equally likely. Which events? Of getting number 1 or 2 or 3 or 4 or 5 or 6 on the top. What do you mean by equally likely? Means we cannot expect occurrence of one in preference to other. So chance of getting 1 is the same as chance of getting 2 up to 6, and each is 1 upon 6 because there are 6 scores. In case of 15, probability would have been 1 by 15 in case of equally likely events. That is why I have written here sample space is 1, 2, 3, 4, 5, 6. So it is P of x, probability mass function. It is 1 upon x for x equal to 1, 2, 3, 4, 5, 6. Now expected value is sigma xi pi. So 1 into 1 by 6 and so on. I hope you remember the formula. This is sum of the first 6 natural numbers, n into n plus 1 upon 2. So expected value, that is mean, is 3.5. So what is E of x square? Sigma xi square pi. Now 1 upon 6 into, it will be 1 square plus 2 square up to 6 square. Sum of the squares of first n natural numbers, n into n plus 1 into 2n plus 1 upon 6, where n is 6. So 91 by 6. Now what is variance x? E of x square minus square of e of x. So 91 upon 6 minus square of this. You may say 91 upon 6 is 15 point something. And what is square of 3.5? It is 12.25. So you can write that also. But here I have written 3.5 means 35 by 10 as 7 by 2. So its square is 49 by 4. LCM is 12 and so on. So I'm getting variance as 2.9167. 11 sum. Find the mean number of heads in 3 tosses of a fair coin. Now when 3 coins are tossed, what will be the sample space? It is written n of s equal to 8. Now we are asked to find mean number of heads, and that is why we define capital X random variable as what? Number of heads. Now 3 coins are tossed. So X can take values, not a single head. So X equal to 0, 1 head or 2 head or 2 heads or 3 heads. Now find out corresponding probabilities. It is better if you prepare that table. Otherwise, write as a probability mass function. Now it is P of X equal to 0 means not a single head, means all tails. So only one sample point T is in favor. So 1 out of 8, so 1 by 8. P of X equal to 1, exactly one head. HTT, THT, TTH, 3 are in favor out of 8. So 3 by 8. P of X equal to 2, exactly 2 heads, 3 are in favor. All the 3 heads, only was in 1 in favor, HHH. 1 out of 8, so 1 by 8 is the probability. Now it is mean expected value sigma xi pi. So 0 into 1 upon 8, that is 0, plus 1 into 3 upon 8, plus 2 into 3 upon 8, plus 3 into 1 upon 8, which is nothing but 12 upon 8, that is 1.5. So this is nothing but you can say expected value or mean. What is asked? Mean number of heads. So mean number of heads is 1.5. Sum number 12. 2 dice are thrown simultaneously. If X denotes the number of sixes, find the expectation of X. Now when 2 dice are thrown, there are how many? 6 into 6, that is 36 sample points in the sample space. Let capital X denote number of sixes when 2 dice are thrown. So as 2 dice are thrown, there are 3 possible values of X, not a single 6, 1 6 or 2 sixes. So let us find how many sample points are in favor of not a single 6. So 1 1 1 2 up to 1 5, 2 1 up to 2 5, 3 1 up to 3 5, 4 1 up to 4 5, 5 1 up to 5 5. So 25 sample points are in favor. So what is P of X equal to 0? It is 25 upon 36. For X equal to 1 means exactly 1 6. So 1 6, 2 6, 3 6, 4 6, 5 6, 6 1, 6 2, 6 3, 6 4, 6 5. So how many are in favor? 10 out of 36. So probability P of X equal to 1, 10 by 36. Now for X equal to 2 means 2 sixes. Only one sample point 6 6 is in favor. So 1 out of 36. So what is P of X equal to 2? 1 upon 36. Now what is expected value? That is mean. It is nothing but sigma xi pi. So first part is 0 into. So I directly write 0 for that. Plus 1 into 10 upon 36 plus 2 into 1 upon 36. So it comes out to be what? 12 by 36, that is 1 by 3. See, in CET, you need not find P of X equal to 0 for expected value. Why? Because whatever may be the probability, 0 into is going to be 0. Actually, in board exam also, they should allow that anyway it is going to be 0 into. So why to find the probability? But in board exam, I repeat, in board exam, you have to write all this if you want full marks. Okay. So what is the expected value? The expectation of X is nothing but 1 upon 3. So that's it for today. In fact, 13 sum for homework. Just a minute. Let me read the sum. 2 numbers are selected at random without replacement from the first 6 positive integers. Let X denote the larger of the 2 numbers. Find E of X. Okay. We will solve this. You can try. I'll give the answer. So tomorrow we will solve this. Answer is 14 by 3. So that's it for today.